Dear students, in this module, we will be covering the topic on descriptive statistics. In social science research, it is common to collect large size data either from primary or secondary sources, which is said to be raw data. Such data is generally not that meaningful and be able to understand either by the researcher or by the concerned stakeholders. At this juncture, the raw data will be analyzed with the help of several statistical measures or tools so as to make the data into meaningful and understandable format. These statistical measures are broadly categorized as descriptive statistics and inferential statistics. At this juncture, the raw data will be analyzed with the help of several statistical measures or tools so as to make the data into meaningful and understandable format. These statistical measures are, let's start with the descriptive statistics, its meaning and importance. Descriptive statistics in general are statistics that quantitatively describe or summarize features of a collected data or information in manageable form. These statistics are used to describe the basic features. For instance, they provide simple summaries about the sample and the measures. With the descriptive statistics, one can simply describe what is or what the data shows. It helps us to simplify large amounts of data in a sensible way. Each descriptive statistics reduces lots of data into a simple summary. Descriptive statistics, in short, help describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data. The most recognized types of descriptive statistics are the mean, median and mode. They are also generally known as measures of central tendency, and statistics like range, standard deviation, coefficient of variation, etc., which are used in at almost all social science research studies. Further, both these measures use graphs, tables and general discussions to help people understand the meaning of the data being analyzed. Researchers use descriptive statistics to reproduce hard to understand quantitative insights across a large data set into bite-sized descriptions. Descriptive statistics are just descriptive. They do not involve generalizing beyond the data at hand. Generalizing from our data to another set of cases is the business of inferential statistics. Basically, all the statistical tools or measures under the broad category of the descriptive statistics, they are of two types: measures of central tendency and measures of dispersion. Let's focus on measures of central tendency. Statistical measures such as mean, median and mode are the well-known ones under this type. These measures are useful to describe a set of observations with a single value that commonly represents the average characteristic of frequency distribution of a piece of information, characteristics or variable under consideration. Average or single value is generally located towards the center of the distribution. Each of these measures provide a way of reducing mass or large data of a characteristic or variable into a single representative value. Besides these three commonly used measures, at times researchers use positional measures like quartiles, deciles and centiles. However, details of these are not discussed in this module as their use is very minimal in social science research. Let's focus again on mean. The mean or average, also known as arithmetic mean, is probably the most commonly used method of describing central tendency. To compute the mean, all we do is add up all the values, for instance x1, x2, x3 and so on up to xn of a variable or characteristic and divide it by the number of values n. For example, the mean or average age of 10 women in a village is determined by summing all their individual ages and dividing the sum by the number of sample women. Example, consider the age of these 10 women: 15, 20, 27, 34, 22, 19, 25, 24, 28 and 30 years. The sum of these 10 values is 167. So, the mean is 244 by 10 is equal to 24.4 years. For computing the mean, the computational formula is as given below. Mean usually denoted as x bar is equal to summation of xi divided by n, which is equal to x1 plus x2 plus x3 plus and so on up to xn divided by n, where x bar the symbol used for mean, sigma symbol for summation, xi values of ith item of x, I to 1 to 3 to dash n, n total number of items. Generally, when large set of data is to be analyzed, the means will be computed for certain values based on the frequencies f of each values of the variable or characteristic x. In such cases, the computation of the formula will be as follows: sigma fi xi is equal to f1 x1 plus f2 x2 plus f3 x3 plus and so on plus fn xn whole divided by sigma fi or capital N f1 f2 f3 and up so on up to fn, where xi is the value of the ith item of x1 x2 so on xn, fi the frequency of the ith item corresponding to x1 x2 dash dash xn, sigma fi is the total number of sample cases n. The table below is the computation of the average number of children of 300 sample women, and the frequency distribution of women by number of children they have is presented, and the mean is the total of 869 divided by the number of women 300 is equal to 2.90 is the average number of children the woman has. Advantages of mean: it is the simplest to compute and widely used one. All the data is used to find the answer. Comparison of means of different groups of data is easy. It can be used for further statistical calculations. It is a relatively stable measure of central tendency. What are its disadvantages? Mean, for instance, very large and very small numbers affect or distort the mean value. The mean may give a result in most cases which is not found to be in the series. Sometimes the arithmetic mean gives a result which is not only absurd but also misleading. The second median value is the average which usually we work out in the social science research. What do you mean by median? Median is central item or positional average of series when it is arranged in ascending or descending order of the magnitude. It generally divides the series into two halves. In one half, all items are taken and less than median, whereas in the other half, all items have values higher than the median will be there. For example, if a series of items are based on odd numbers which are arranged in ascending order, say for example 3, 4, 6, 7, 8, 9, 10, the median value is the midpoint 7. If a series of items are based on even numbers which are arranged in ascending order as 2, 3, 4, 6, 7, 8, the median value falls between 4 and 6 and thereby it is 5. The computation formula for median is equal to value of n plus 1 divided by second item, which is equal to 4 plus 6 by 2, that is equal to 5. In the case of frequency distribution of a series of data, the median value would be computed by finding out n plus 1 by 2 value that falls in the cumulative frequency of the series. For instance, in the table 2, you can see the frequency distribution of women by number of children they have, and in the present case such values will become 300 plus 1 divided by 2 is equal to 150.5, which falls in the cumulative frequency category of 204. For this category, also called as a median class category, the value of item on x is 3, that is 3 number of children is the median for this series of data. What are the advantages of median? It is easy to calculate. The extreme values in a series would not affect this measure. It is useful in the case of those facts which cannot be measured in terms of quantity. The disadvantages of median are mainly it takes long time to estimate in the case of large data. In the case of individual series, item values need to be placed in any order, which is a little bit tedious. Also, there is a general controversy about the gininess of the tau disputed formula, that is n by 2 or n plus 1 by 2. The third measure is the mode, which is the simplest of all averages. It is the item or measure that occur most frequently in a series or distribution. For example, in a series of items such as 3, 5, 6, 10, 9, 6, 5, 7, 6, 8, the value 6 has occurred more frequently, that is 3 times. Hence, the mode of this series is 6. In the case of frequency distribution of a series of data, as provided in example T at 2, the number of children reported to be frequently occurring among majority of women, that is 82 in number, and thus the mode of this distribution is 3. What are the advantages of mode? It is the simplest of all measures of central tendency. It can be used for qualitative distribution also. It is the most appropriate for nominal level of data. It is also not affected by the extreme values of a distribution. In the case of its disadvantages, not at all useful for further statistical analysis. It is quite unstable. Sometimes there may be more than one mode. It may not accurately represent the data under consideration. Now, all these measures, mean, median, mode, after we see this individual calculation, it can be clearly seen that it is used to be computed for grouped data or distribution, which is little bit time consuming. However, in the recent past, most of these measures are not manually computed by the researchers. Several ready-made and user-friendly software are used for this purpose, through which all these measures would be computed in a fraction of a second. But the researchers need to understand these mechanisms so as to understand the data and interpret the same in a meaningful way. Let us discuss about measures of dispersion. Measures like range, mean deviation, quartile deviation, variance, standard deviation, coefficient of variation, skewness and kurtosis fall in this category. These are also known as measures of variability or spread. These measures will provide the idea about how the values of distribution are closer or compactly or far away or scattered from the central or position values of that distribution. Most of the social science researchers in general and those belong to population studies in particular use the following measures of dispersion like range, standard deviation and variance. Hence, in this module, an attempt is made to discuss the importance and computation of all these three measures. Let us start with the discussion on range. Range R measures the difference between the highest and lowest values of a distribution or series of a variable. Suppose in a survey, age distribution of women varies from 15, 16, 17 up to 46, 47, 48, 49. The range of difference between 15 and 49 is 34. That is, highest value of 49 minus the lowest is 15. The difference is 34. In the case example provided, the range is 6, which is highest is 6, lowest is 0 and the difference is 6. Thus, it can be applied in cases where the distribution is least or an ordinal level of measurement. What are advantages of range? It is very easy to compute and understand. It can be used as a measure of variability where precision is not required. For instance, size of the standard deviation is approximately 1/6 of the size of the range. What are the disadvantages of range? The value of range is affected by two extreme scores. It is not very stable from sample to sample. It does not give any information about the pattern of variation. Let us discuss about standard deviation, which is very commonly used. Standard deviation is the most widely used measure of dispersion of a series and is generally denoted by the symbol sigma or at times S. It is defined as the square root of the average of squares of deviation when such deviations for the values of individual items in a series are obtained from the arithmetic mean or average. Thus, the standard deviation shows the relation that set of scores has to the mean of the sample. In the case of a series of observations or for a discrete variable made up of n observations is the positive square root of the variance and is S is equal to square root of sigma of x minus x bar whole square divided by n. What are the steps to compute standard deviation for a discrete variable? First, calculate the mean, subtract the mean from each observation, square each of the resulting observations, add these squared results together, divide this total by the number of observations, that is variance S square, use the positive square root, that is standard deviation S. Computed of standard deviation for the following data of age 10 years, 10 women in years are, for instance, if the data is 15, 20, 27, 34, 22, 19, 25, 24, 28 and 30, the mean of this series becomes 24.4. The computation of standard deviation for the given data on age of women is presented in table 3. In the case of data on frequency distribution, the standard deviation is computed with the formula as given below. Sigma is equal to square root of sigma f bracket x minus x bar whole square divided by sigma of f, where f is the frequency of each of the value on x minus x bar is the deviation from mean for each value of x, sigma f is the total number of frequency of the sample. Table 4 provides computation of standard deviation for the frequency distribution of women by number of children. The table clearly indicates the mean for the data given above is 2.9 and standard deviation is square root of 697.50 divided by 300, which is equal to 1.513. Here one should interpret that the mean number of children of the sample woman would vary within the range of plus or minus from the mean. That is, from the lower side of the mean would be 2.90 minus 1.51, which is equal to 1.39, and at the higher side it would be 2.90 plus 1.51, which is 4.38. This means that there is about 95% sure that a sample woman is likely to have children in the range of 1.39 and 4.38 during her lifetime. Statistically, if the value of standard deviation is small, that mean of the distribution or data is said to be fairly good or reliable. What are the advantages of standard deviation? It is the most accurate and reliable measure of dispersion. It is more resistant to sampling fluctuations or variations. It is more amenable to further statistical treatment both in descriptive and inferential statistics. Disadvantages of standard deviation: it is responsive to exact position of each score or value in the distribution. It is highly sensitive to extreme values in the distribution. At times, its calculation is time consuming and a bit difficult to understand. The next means of measures of dispersion is variance. In probability theory and statistics, variance is the expectation of the squared deviation of random variables from its mean, and it informally measures how far a set of random numbers are spread out from their mean. This means it will be easy to compute the variance because as it is based on the standard deviation. The variance has a central role in statistics. It is used in descriptive statistics, statistical inference, hypothesis testing, goodness of fit, and many other such cases. This makes it a central quantity in numerous fields such as physics, biology, chemistry, economics, and finance. However, its use in social sciences is somewhat limited except in commerce and business management. The variance is the square of standard deviation, which is often represented by sigma square or S square. Alternatively, it can be computed by the formula sigma square is equal to sigma of x square divided by 1. For example, based on the example provided in table 3, if variance is 288.20 divided by 10, that is equal to 28.82. Based on the example provided in table 4, variance becomes 2.29. As stated earlier, although we can calculate all the descriptive statistics manually or by hand, it will be quite tedious when we have more than a few values and variables. Therefore, almost all the researchers in the recent past are making use of statistical software programs to compute all these statistics very easily within a few seconds or after entering the data. Thus, though most of these computations are not necessary for the researchers, their importance and uses and the mechanisms of such computations are very much essential to understand these clearly so as to use these measures appropriately in our research endeavors. In that sense, when we see that measures of central tendency and also measures of dispersion, it is very important for us as a researchers, we need to understand in what context we have to use each of these measures. When we talk about arithmetic mean or median or mode, we need to know what is the type of data which we are having and what type of appropriate descriptive statistics which that is required for the use. At that time, you have to be very careful in choosing the appropriate measures of central tendency. As we have seen that each measure has its own advantages and it has its own disadvantages. The researcher has to use appropriate method depending on the type of data and also the type of information that needs to be taken while analyzing the data. Also, if we look at some of these measures, they have a very interesting that they can be used for further analysis. For example, when we use some of the data by using appropriate statistics like mean, then it is interesting that it can be adopted for further statistical inference and also different statistical methods at higher levels. For example, if you move from bivariate to multivariate, such measurements makes a lot of difference and they form the basis for further calculations. And at the same time, we also should see how much your data permits for using such methods. For instance, when you want to use mean or median or mode, your distribution also, the data and its distribution are very important for us to understand first. Similarly, when we talk about measures of dispersion, whether we want further statistical inferences to be drawn, whether we are going to use higher statistical techniques, and then we should take a decision whether which appropriate method should be used for each of these methods. Similarly, the type of data, whether it is a micro level data or a large scale data set which you are using, also makes a lot of difference in choosing the appropriate method of measurement of central tendency or measurement of for dispersion. The other aspect which we need to know is how best you can communicate in its presentation. That is also very important, because the more the applied way of interpreting and bringing it out to the people for whom this analysis is meant for, also makes a difference for understanding and using a particular type of data set and the type of descriptive statistics. And furthermore, for building up various statistical measurements and further additional statistical treatment that needs to be used, this descriptive statistics forms a solid base for us to understand, so that the further techniques and the adaptation of various tools and these things also makes a difference for your interpretation. So, students, in this module we have covered what are the different definitions that are used for descriptive statistics, and in the descriptive statistics broadly we have seen what are the various measures of central tendency and what are the various measures for measures of dispersion. These two are very important. Measures of central tendency will give you one information, one unit which will be representative for the rest of the data. At the same time, measures of dispersion will clearly reflect on how much variation that has come from that number, which comes out as a mean, median or mode, from the remaining data, which gives a extent of variation for us to understand. Also, we need to see that higher the variation, the distribution is not to that extent proper, and also consistent is questionable. So, that is why the measures of dispersion should be minimum. At the same time, if it is also used that particular method of data for which you need to adopt higher levels of analysis and calculation, then appropriate statistical method is very important, whether it is in the case of measures of central tendency or in the case of measures of dispersion. So, to that extent, the descriptive statistics forms a solid base for us to begin, so that we will clearly understand how it can act as a base for further analysis as we move on through different modules in the class.